We're going to write a balanced equation for the given redox reaction in acidic solution using 4 simple steps. If you're looking for basic condition, do stick around as it only takes one extra step and we'll get to it at the end. Step 1. We have to write out the half equations. To do that, we'll figure out the oxidation number for each atom and then we're going to use that to find our oxidation and reduction equations. From the oxidation number, it looks like Cl2 going to ClO2 minus is going to be an oxidation equation because the oxidation number of chlorine increased from 0 to +3, whereas Cl2 going to Cl minus is a reduction because the oxidation number for chlorine decreased from 0 to -1. Now we can write out our half equations. For oxidation, it's Cl2 going to ClO2 minus, whereas for reduction, it's Cl2 going to Cl minus. Next step, we need to balance the atoms and we need to do that following this sequence. If we don't follow this sequence, we're going to end up using more time than is necessary. So we start with our oxidation equation. We need to balance all atoms except for oxygen and hydrogen. So we have 2 chlorine on the left and 1 chlorine on the right. So we're going to have to add a 2 in front of ClO2 minus. Next, we balance oxygen using H2O. On the left hand side, we don't have any oxygen. On the right hand side, we have 4 oxygen. So that means we're going to add 4 H2O on the left hand side. And because of that, we now have 8 hydrogen on the left hand side and no hydrogen on the right hand side. So we're going to add 8H plus on the right hand side. And with that, we're done with balancing oxidation half equation. Let's move on to the reduction. We need to do the same thing here. We start with Cl. We have 2 Cl on the left hand side and 1 Cl on the right hand side. So let's add a 2 in front of the Cl minus. And next, we're supposed to balance oxygen. Since there's no oxygen in the equation, we'll skip it. And now we move on to balancing H. Since there's no H either, looks like we're done balancing the reduction equation. Moving on to step 3, we need to balance the charge by adding electrons. From the oxidation equation that we've balanced, the total charge on the left hand side is 0 because Cl2 and H2O are both neutral compounds, so the total charge is 0. On the right hand side, we have 2 times -1 from 2 ClO2 minus and +8 from 8H plus, and that gives us a total of +6 on the right hand side. In order to balance the charge, we need to add 6 electrons on the right hand side. That way, the total charge will become 0 and both sides will have the same charge. So let's do the same for the reduction equation. Left hand side, we have a total charge of 0 and right hand side, we have a charge of -2. So to balance the charge, we're going to have to add 2 electrons on the left hand side so that now both sides have the same charge, which is -2. Now that we've balanced the charge on both sides, we need to now make sure that the number of electrons in both the oxidation and reduction equation are the same. So for oxidation, we have 6 electrons, whereas for reduction, we have 2 electrons. So in order to make the number of electrons the same, we're going to have to multiply the entire reduction equation by 3, and that will give us 6 electrons. Here's a pro tip when adding the electrons. If you're adding electron for oxidation equation, make sure that you add it on the right hand side, whereas if you're adding electron for the reduction, make sure it's added on the left hand side. Moving on, now that we've done all the hard work, let's add up both equations to give us the balanced equation in acidic condition. From oxidation, we have Cl2 and 4H2O, and from reduction, we have 3 Cl2 and 6 electron. Don't forget that 3 that we multiplied. On the right hand side, we have 2 ClO minus and 8H plus 6 electron and 6 Cl minus on the right hand side. Let's simplify the equation. We'll cancel out terms that appear on both sides of the equation. In this case, we have 6 electrons on both sides, so we're going to cancel them out. After we simplify, we rewrite the equation. We have 4 Cl2 plus 4 H2O, giving us 2 ClO2 minus and 8H plus and 6 Cl minus. That's our balanced equation in acidic condition. Basically, we're done answering the question at this point. Just in case you're looking for a basic condition, we'll add one more mini step, and that is to add OH minus on both sides of the equation for every H plus that we see. So from our acidic condition, we have 8H+. So that means we're going to add 8OH- on both sides of the equation like this. On the right hand side, that 8H+ and 8OH- is going to combine to give us 8H2O. And then we can simplify it, and that will give us 4H2O on the right hand side. So now we rewrite the equation and we get 4Cl2 plus 8OH-, giving us 2ClO2- plus 4H2O and 6Cl-. That's our balance equation in basic condition. To recap, we went through these 4 steps in balancing the redox equation in acidic and basic condition. When we add electrons in step 3, we need to make sure that we add it to the right side for oxidation and to the left side for reduction. And when we write out our balance equation in acidic condition, we need to make sure that there's H+ in the equation. Whereas if we are writing it for basic condition, we need to make sure that we have OH- in the equation, and there should not be any H+ appearing in the equation. And just to be super safe, we should always double check our work to see if the number of atoms and charges are equal on both sides of the balance equation. I hope the 4 steps in balancing redox equations were helpful. Do subscribe, and thanks for watching.